Hello everyone, this is Sudhir. Welcome back to my class. In this class, I am going to explain you 10th standard first chapter real numbers introduction concept. So what is the real numbers? A real number is the set of rational and irrational number. What is rational and what is irrational? So let us discuss now. And you know very well, in the number system we have different type of number, that is like natural number. You know natural number begin with 1, 2, 3, 4, 5, so on. These all are what? Yes, it is natural number and it is denoted by capital N. Correct? Now, next one, the number which is begin with 0, like 0, 1, 2, 3, 4, so on. This is what? It is whole number denoted by W. Now, along with this, we have some negative number like -2, -1, 0, 1, 2, 3, so on. So this is what? Integers. It is denoted by capital Z. That means integer means the number that is a positive number and negative number along with 0. That is integer. Now rational numbers, next one. So rational number means the number which can be written in P by Q form. P by Q form. Okay. So what is P by Q form? Like rational number 2 by 3. Or decimal number you take like 2.1 and 2.34, 34, 34, so on. How to write this 2.34, 34, 34, so on? That is 2.34. Okay, or 34 bar. So this is fraction number, decimal number, and this one also decimal. This is called terminating decimal and this is terminating repeating decimals. Okay, so these all numbers together are called P by Q form number, that is a rational number. So natural number, whole number, integer, rational numbers all together are called that is completely a rational number. Now let us discuss what is irrational number. So irrational numbers mean a number which cannot be written in P by Q form. So what type of number we can't write in the P by Q form? There are the two type of decimal numbers we have discussed. One is terminating and another one is non-terminating. Okay, so terminating and non-terminating. What is the terminating decimal? For example, the number you have like 2 by 5. So how to divide this one? With 5 you can divide this 2, right? So you take 0 point and keep a point here, 4 means 5 4s are 20. So here it is 0.4. So this type of number, that means when you dividing a fraction, if you get a remainder 0, then the type of decimals are called terminating decimals. And non-terminating decimal mean, for example, 3 by 7 I am taking. That means with the 7, if you divide this 3, take a 0 point. Okay, so 7 4s 28, and you get here 2 point is there, take a 0. Again 7 2s are 14, so 6 is there, and because of this point we take here 0. So 7 8s are 56, so on. So on. It should be continue like this. So this type of numbers are called non-terminating. Non-terminating. It is what type of decimal it is? So non-terminating decimal. But in non-terminating again we have the two type of decimals. One is recurring and non-recurring decimals. So recurring decimal mean if the number is repeating, so on. Like for example, if I continue this process here, I will get the remainder is 4. Okay, the point is there here, so 0. So 7 5s 35. Again I should get here yes. Now here what we should get, that is 5. Okay, so because of the point, if I take 0 here, so 7 7s are 49. Okay, so remainder is 1. Now by taking a point here, so 0, that is 10. So 7 1s are 7. So remainder we get again 3. point is that 0, so 7 4s are 28. So this process will be continuous. See, after getting this 4 here, these whole numbers it will be repeat here, like 4 2 8 5 7 1, so on. That means how to write this number, that is 0.428571. So for this all we have a bar. Okay, so this is called the non-terminating repeating decimals or recurring decimals. Non-terminating, non-repeating decimals are there. That means for suppose you can take like 2.367325297611532. Okay, so on like this. So this is non-terminating, non-repeating decimal. So because one particular order is not there here, so this type of number you cannot convert into P by Q form, so that these numbers are not a rational number. This one and this number is example for irrational numbers. So this type of decimals you can't convert as rational numbers, so that it is irrational numbers. So what are the irrational numbers? In the irrational numbers we have like square root values like root 2, root 3, root 5, not a root 4, because root 4 means again 2 you can write as a P by Q form, it's a rational, and root 6, so on. This type of number. Even pi also irrational number. In the 9th standard you will learn why pi is an irrational, right? And so you can see in the previous page, so this type of number, that means the terminating and non-terminating recurring decimal, non-terminating recurring decimals you can convert into P by Q form. So these type of numbers are rational number. Rational means natural number you can take, whole number, integers, and some decimal numbers like terminating and non-terminating recurring decimals and fraction numbers. These all are together we call rational numbers. So now real numbers mean the set of the rational and irrational numbers are called real numbers. So here I should draw one rough figure to understand what is the concept here. Okay, right. See, here I am going to draw the first one is natural number. Okay, natural number started with 1, and this natural number is a subset of a whole number, because here we have a 0 and remaining all are natural number like 1 2 3 so on. And these all are, that means natural number and whole number is a subset of integer, because in integer we have natural number, that means positive number, and 0, along with them some negative values like -1, -2, -3 so on, right? And these all together, and because these all are in the subset of a rational number generally denoted by Q. Okay, irrational number is the separate again. So irrational number is completely different than this natural, whole number, integer, and a rational number. These all together, okay, these all together we called it is, okay, see here I am going to take this all now. So this complete number system is called, is that, yes, it is real numbers. So I hope you understood this introduction part, what is a real numbers. Now we will discuss some problems. That is, for suppose if I give you a number like 35 and you need to divide this 35 by 2, so how can you divide it, right? So you can divide like this, and you write here 2 1s are 2, and you get remainder 1 and bring down this 5, 2 7s are 14, so remainder you get 1. So this is called divisor, and this is dividend, this is quotient, and this is a remainder. This is what? It is a dividend, and this is divisor. Divisor, dividend, quotient, and a remainder. So how can you express this one now? Like 35 is a number, this dividend is equal to, you know what is the divisibility rules there? So dividend is equal to divisor into quotient plus remainder. That means 17 2s are 34 plus 1 is equal to 35 you get. So for suppose the same number, if you divide by 3, then what you get? 3 if you divide this 35, 3 ones are 3, again 3 ones are 3, remainder you get 2. So how to write this? This 35 equal to 3 into 11 plus 2. So 11 3s are 33 plus 2 35. So for suppose this 35 if you divide by 4, and what you get here? 4 8s are 32, you get remainder is 3. That means if this 35 if you divide by 4, 4 8s are 32 plus 3 is equal to 35. Now if you divide by the 5, then 7 5s are 35, right? So if this number is divided by, that means 35 is divided by 5, 5 7s are 35 and you get remainder is 0. Now in this process just you can check here, remainder here you got 0, so remainder you got here 0. Then this is what? It is a divisor and it is a coefficient. So in this case here 5 and 7s are both are the factors of 35. 5 and 7 both are factors of 35. When it is? When you get a remainder is 0. When the remainder is 0, then this 5 and 7 the both are the factors of 35. So and in this case this 5 is called HCF or 7 is called HCF of a 35. Okay, so we need to discuss now what is the HCF by using Euclid division lemma concept. So we have a Euclid division lemma topic, so let us discuss. For suppose here one sample question is there that A equal to 13, B equal to 3. Okay, so we need to write this one in the form of like A is equal to BQ plus R. Don't get any confused what is this A is equal to BQ plus R. Here A is the dividend just before we have discussed. So let us check one more time here. So this one is compared with like A is equal to BQ plus R. Here A is the dividend, B is the divisor, Q is coefficient and R is remainder. Okay, so A is equal to BQ plus R in this. So we need to write in this form. The question is find Q and R for the following pair of positive integers A and B satisfy A is equal to BQ plus R. So first of all we should write this A equal to 13 and B equal to 3 in the form of A equal to BQ plus R. Then you are going to divide with this 3 because this is the divisor, right, and 13 is the dividend. So 3 4s 12 and the remainder you get it 1. So this 13 we should write as 4 into, sorry, that is 3, right? Divisor is 3, coefficient is 4 and the remainder is 1. Now in this case you check here, this is B equal to 3. So the question is asked what is Q and R. So Q equal to 4, that is a coefficient, and the remainder is 1. Okay, so let us discuss one more problem in the same order. This time A is equal to 125. A is equal to 125 and B is equal to 5. So with the 5 you need to divide this 125, then what you get here, 5 2s are 10 and the remainder you get 2. Bring down this 5 here, so 5 5s are 25, remainder is 0. So what is 125 equal to be right now? 125 is equal to A is 5 into 25 plus 0. Okay, so if you compare this one with A is equal to BQ plus R, A is equal to BQ plus R. So what is A here? That is the dividend, B is the divisor, Q is the coefficient and R is remainder, that is equal to 0. So this is the model to find HCF. So actually the question is asked to write in the form of like A is equal to BQ plus R. Now we will discuss what is the HCF and how to find using Euclid division lemma. So there is Euclid division lemma definition here, that is, so what is Euclid division lemma definition? Given positive integer a and b, given positive integer, so this is called the statement of, here I am writing the spelling. Okay, so Euclid's division lemma. So what is the statement of Euclid division lemma here? Given positive integers a and b are, there exists a unique pair of the integers q and r satisfying a is equal to bq plus r. That what before we have discussed, a is equal to bq plus r, and there is a condition, that is 0 is less than or equal to r less than b. That means this remainder is, it should be either 0 or more than 0, but it should be less than b. B means your divisor. Okay, you take here any example. The before one we have discussed many examples here. So the remainder definitely you will get. So the remainder definitely will get less than divisor here, right? And in this case also you can check, remainder is definitely less than the divisor. And check this example also, remainder is less than the divisor. So that we take this condition. So remainder, it should be a 0 or more than 0, but it should be less than divisor. So this is a very important condition for this, and we will discuss some examples now how to find the HCF. So here given in page number 40 in your textbook, in the page number 40 they gave in the do this, so find the HCF of the following by Euclid division lemma. So the question is the first one, 50 and 70 given, 50 and 70. So how to find what is, that means this Euclid division lemma. Using Euclid division lemma we need to find a HCF. So the first process, first we take here 50 as the divisor, because the 50 is a small number, so definitely we take this one as the divisor, and 70 is the dividend, and 50 ones are 50 minus then 20 you will get. With this 20 you need to divide this. Okay, remainder you got 20 now, so just to bring down this 50 here. Okay, just I am showing you how to divide, I mean how to find the HCF using the division method. This already you have completed in your 6th and 6th standard, right? 6th and 5th standard. But in the 10th standard we should not do like this. We should apply Euclid division lemma concept. That one we'll discuss. But first you must understand what is the actual process. So how to find the HCF using division method. So with the 20 when you are dividing this, so 20 2's 40. Okay, so remainder is, when you subtracted from 50 this 40 you will get it 10. Now again bring down, so this 10, so bring down this 20 here, so 10 2's are 20, remainder 0. So here we got remainder 0 at 10 as the divisor. So that this 10 is called HCF. This 10 is called HCF. So once again in Euclid division lemma we will write this one like a is equal to bq plus r. In this form we should write this. So what is a? That is dividend 70 equal to bq. B means 50. See this 50 into 1 plus 20. Okay, 50 into 1 plus 20. If you check this 51s are 50 plus 20 equal to 70. In the next step again this 50 equal to, we write here 20 into 2 plus this 10. Okay, and in the next step again, so this 20, see 22's are 40 plus 10 is 50. This 50 we got, right? Now in the next step we write this 20. So this divisor we can take as the dividend. For this we write 10 into 2, sorry, have 10 into 2 plus the remainder is again 0. So observe this one. So you got here 0 at this point. Here in the place of B we have 10. So that the HCF is 10. Actually, without doing this one also you can write whole this process, because actually this is the important in the 10th standard, this model finding HCF using Euclid division lemma. I mean, like this only we do, but this process is for your understanding how to write that number. Okay, right. Now one more question we'll discuss. 96 and 72. 96 and 72. So how to write this 96 and 72? So 72 is a small number, right? 72 is a small number, so that's the reason we write here this 96. 72 one times you can divide, right? 72 ones are 72. From 96 if you subtract 72, what you will get? That is 24. Okay, so again this 72 we get here. So 72, how can we write it? The 72 you should divide it by, so if you had it out already, I shown how to divide this using division method. This 96, okay, this 96 divided this 72. 72 ones are 72 and the remainder you have 24. So this 72 into 1 plus 24, that step only I have written here. So 74 and just bring down this 72 here. 24 3 is 72, remainder 0. So this 72 again we write 24 into 3. 72 we write 24 into 3 and remainder you got 0. Okay, so you can observe at 0 we have a 24 here. This is a divisor, so this is called the HCF. In this problem HCF is 24. Okay, so this is the model. Using this model we are going to solve some more problems in the exercise 1. Okay, so in the next class we will discuss again how to find the HCF using Euclid division lemma. So that's the topic today. So complete introduction I have given you, but it belongs to like first exercise concept, right? So this is the topic today. So this is Sudhir. Thanks for watching. See you soon.